As we are on to this RISE review graphing systems in standard form notes and practice. Actually, it's all together. So I'm going to go through how we solve these systems of equations when maybe one of the equations or both of the equations aren't written in slope-intercept form. Slope-intercept form, remember, is y equals mx plus b. But sometimes we're given equations that are in standard form. What's standard form? Well, that's the very first thing listed there. So ax plus by equals c is standard form. So basically the x and the y are on the same side of the equal sign. And then we just have our constant by itself on the other side. Okay. So they give us two examples here. I can't tell, excuse me, I can't tell what the slope is from that equation. I can't tell what the y-intercept is from that equation because it's not in slope-intercept form, right? And then the same thing for this one. I can't tell what the slope or the y-intercept is. I have to get y by itself. That's the key difference between standard form and slope-intercept form. So they have an example here. We're going to solve this system. So it says when you have a system and one or more of the equations is in standard form, you can still solve the system by changing the equations to slope-intercept form and then graphing and seeing where they cross. Remember, that's the solution, is where the two lines meet. So that's what we're going to do here. I'm going to change each of these into slope-intercept form. Okay. So first thing I'm going to do, this first equation, zoom in so we can see that a little bit better. Draw my wall, and I want to get rid of the x term. That's always your first step. Get rid of the other term. Okay, so here's y right here, right? I'm not going to get rid of that first. I'm going to get rid of the other term first. So subtract 3x from both sides. Those cancel because 3x minus 3x, anything minus itself is 0. That leaves me with 2y equals, and now I like to put it so that this term, let me change my color here, this term comes first after the equal sign because that's how slope-intercept form is, right? Let me write that up here. Y equals mx plus b. I want that x term to come first after the equal sign. So I'm actually going to put the minus 3x first. And then that negative 2 will go at the end, the minus 2. Y isn't by itself yet. It's being multiplied by 2. So I'm going to divide by 2. And I'm going to do that to every number on the other side as well. Remember, whatever we do to one side, we have to do to the other. So 2 divided by 2, they cancel. It just equals 1. And I don't have to write the 1, it's just y. Negative 3 divided by 2, so look at this first, right? Negative 3 divided by 2, that gets me negative 3 halves x. And then negative 2 divided by 2. A negative divided by a positive is a negative, so negative 1, because 2 divided by itself is 1. All right, so that's my equation in slope-intercept form. I'm going to center that up a little bit. So I've got y equals negative 3 halves x minus 1. Now that it's in slope-intercept form, I can go ahead and graph it. Remember, start with your y-intercept. Graph that first, and then use your slope. My slope is negative 3 halves, so negative 3 over 2. That tells me I'm going down 3 and to the right 2 from that y-intercept. So negative 1, let's graph that first. So over on this graph, put a point at negative 1. And then I'm going down 3 to the right 2, down 3 to the right 2. So 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Once you've gone as far as you can one direction, go back to your beginning point and do the opposite. Go up 3 and to the left 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. I can do it one more time. 1, 2, 3, 1, 2. That's my first line. That's the line that goes with that first equation. For the second equation, I'm going to do the same thing. I'll change colors here real quick. I'm going to do the same thing. I'm going to get y alone. So draw my wall. And just like I did on the other problem, I'm going to get rid of the x term first. So I'm going to subtract x from both sides. X minus x is 0. I'm left with 2y equals, and again, I'm going to put that x term first. I'm going to put that minus x first, and then bring down the negative 6. Okay, just because that's how slope-intercept form is. Okay. Y isn't by itself. It's being multiplied by 2. So I'm going to divide both sides by 2. That gives me y equals, now there is a 1 in front of that x, so this is really negative 1 divided by 2. So that's negative 1/2 x. And then negative 6 divided by 2 gets me negative 3. There's my second equation. So again, I'm going to start with the y-intercept, and then I'm just going to write my slope off to the side down here. Negative 1/2 means I'm going down 1 and to the right 2. Okay, so start from your y-intercept, start at negative 3, and then, yeah, use those slope numbers, down 1 to the right 2. Oh, look, we can see right there where it crosses, down 1 to the right 2, down 1 to the right 2, and then one more time, down 1 to the right 2. Then just go back and do the opposite from your beginning point. Up 1 to the left 2, up 1 to the left 2, up 1 to the left 2, and one more time, up 1 to the left 2. Okay, that gets me my second line, but it also gets me my solution, because now I can see the two lines cross right there, but actually write your answer. Okay, that's important. Don't forget to actually write your answer. Your answer is that ordered pair, which that's right at 2, negative 4. And that's my solution. Okay, so you're going to go ahead and try the problems on the next page. I would pause the video now, go ahead and try those, and then when you're finished, unpause the video and see how you did. All right, I'm going to go ahead and show you guys how to solve these. So for all 4 of these problems, the first equation already has y by itself. I can see what the slope and the y-intercept is. So for number 1, for instance, look right here. The slope is 5, the y-intercept is negative 4. Okay, I have to solve the second equation to get y by itself. For number 2, same deal. Look, y is already by itself. My slope is 2, my y-intercept is 4. But I need to solve the second equation to get y by itself, right? And 3 and 4 are the same way. So let's go through these. I'm just going to graph the first equation, y equals 5x minus 4. So minus 4 start here. 5 is not a fraction, but I can make it a fraction by putting it over 1. So up 5 to the right 1. 1, 2, 3, 4, 5 over 1. And then 1, 2, 3, 4, 5 and over 1. So there's the first line. All right, and then for the second one, I've got to solve it. So I'll use a different color. Go ahead, draw your wall, and let's get y by itself. Get rid of the x term first. So start by subtracting 2x from both sides. That gets me y equals, and then I put the x term first. So I'm going to put that minus 2x first. That 3 is positive, so it's plus 3. Now I know my slope. The y is by itself. Now I know my slope and my y-intercept. So I'm going to go ahead and graph that one. Positive 3 is right here. It's a negative slope, so I'm going down 2 and to the right 1. Down to the right. Oh, I can see where it intersects. Down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. So I can't go any further. Go back to my y-intercept, do the opposite. Up 2 to the left 1, up 2 to the left 1, and that's it. Draw your line. And you guys can see the place that they intersect is right there. Don't forget to write out the solution. Okay, don't do all of this work and then not get credit for it. Actually write out the solution. The solution is that point, and that point is at 1, 1. For number 2, I see the top equation I can graph, so I'm going to. Starts at 4 and up 2 to the right 1. It's positive 2 slope this time. So up 2 to the right 1, up 2 to the right 1, and then go back to your beginning point and do the opposite. Down 2 to the left 1, 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 until you run out of space, and then just connect your points. Okay. So there's the first equation. I'll do the second equation in a different color, and I need to solve for y. So I'm going to draw my wall. I'm going to start by getting rid of the x term. I'm going to subtract 2x from both sides. That leaves me with 3y equals, and then I put the x term first, negative 2x, and then I bring it down to negative 12, the constant. Okay. Y isn't by itself yet. I have to divide by 3. So I divide by 3, divide everything by 3, and that gets me y equals negative 2 divided by 3 is just negative 2/3 x, and then negative 12 divided by 3 is negative 4. So I'm going to start at negative 4, and my slope is negative 2/3, so I'm going to go down 2 and to the right 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. And that's all the further I can go in that direction. Go back to your beginning point, do the opposite. Up 2, 1, 2, 1, 2, 3. Oh, I can see where they intersect. Do it again. Up 2, to the left 3. And that's all the further I can go. Draw your line. And we can see very clearly where those two lines intersect. But don't forget to actually write out the answer. It's this ordered pair, okay? Negative 3, negative 2 is where they cross. I'm going to do the same thing for 3 and 4. Graph the first equation. Looks like I'm starting at positive 1. My slope, that number in front of x is a negative 1. So I'm going down 1 to the right 1, down 1 to the right 1, and keep going until you run out of space. Go back to your beginning point, do the opposite. Up and to the left. Keep going until you run out of space. Draw your nice straight line. So I got my line drawn there. Now let's solve the second equation. So I'll use a different color. Got to get y by itself. Always start by getting rid of the x term. So subtract 2x from both sides. That gets me negative y equals negative 2x minus 4. A lot of negatives, negatives everywhere. Y isn't by itself. It has that negative sign in front of it, which really is a negative 1, right? If there's no number there, it's really 1. So I'm going to divide everything by negative 1. Now anything divided by 1 is itself, but since it's a negative, I'm dividing everything by negative. Well, negatives divided by negatives are positives. So everything just turned positive just by doing that one move. I'm going to start at positive 4. And I'm going to go up 2 to the right 1, up 2 to the right 1, until I can't go any further. And then go back and do the opposite. Down 2 to the left 1. I can see where they intersect. Down 2 to the left 1. Finish this out so I can draw a nice straight line. There you have it. Scroll down a little bit. I can see right where they intersect. It's right there at that ordered pair, so actually write out the ordered pair. It is negative 1, 2. And then for number 4, again, first equation's done. Let's graph it. Positive 2, and then my slope is a positive 2/3, so I'm going up 2 to the right 3. Up 2 to the right 3. And that's all the further I can go. Go back to your beginning point, do the opposite. Down 2 to the left 3. Down 2 to the left 3. And that's all the further I can go. Draw a nice straight line, connecting your points. Okay? So the second equation I've got to solve for y. You know it. Get rid of the x term first. So I'm going to subtract 8x from both sides. That gets me negative 3y equals, and I'm going to put the x term first after the equal sign. Negative 8x, that 12 is positive, so it's a plus 12. Y is being multiplied by negative 3, so just divide everything by negative 3. That's going to get me y equals, a negative divided by a negative is a positive, so positive 8/3 x, that can't simplify. And then 12 divided by negative 3 is negative 4. So I'm going to start at negative 4, and I'm going to go up 8 and over 3. Okay, well, that's the only other point I can graph on this one. Okay, so my line is going to look like that. And I can see where they intersect, write out that ordered pair. Again, don't do all this work and not get the answer at the end, okay? Looks like I go over 3 and up 4. All right, moving on. You guys remember that there were special cases with systems of equations, okay? The one solution, the no solution, or the infinitely many solutions. So for one solution, one thing I want us to write down here first is that when I was looking at the equations, for all of those 4 problems that we just did, they all had one solution. They all intersected one time. So what was it about those equations? Well, the slopes are different. Slopes are different. So anytime you're looking at a system of equations, if the slopes are different, boom, you're done. You know they intersect. They're going to intersect one time. They will have one solution. Okay? So one example of that would be something like y equals x plus 2, which that would have a slope of 1, right? There's no number written there in front of x. And y equals negative 2x minus 6. Okay? So if I go to graph both of these, I'm going to see that they intersect once. So start at plus 2 and then go up 1 over 1, up 1 over 1, up 1 over 1, and then go backwards. I have no idea how this is going to work out. I probably should have used the same ones that I used in class for this, but let's see how it works. So the second equation's at starting at negative 6, and it's a negative slope. I can't go down any further. I mean, there's no more space, so I'm going to go ahead and do the opposite. Go up 2 and to the left 1, up 2 to the left 1, up 2. Of course, this is not going to work out very nicely. Up 2 to the left 1, up 2 to the left 1. But that doesn't matter, that it's not a nice ordered pair for us to look at. We can clearly see from this example, oh yeah, hey look, they intersect one time. That's why it's called one solution, okay? But the main thing is here, the slopes are different. That's how you know that they're going to intersect, all right? Now for no solution, think about what that would mean. If one solution means they intersect one time, what's no solution? It means they don't intersect at all, okay? Those are the parallel lines. How do we get parallel lines? That's when the slopes are the same and the y-intercepts are different. So the starting points are different, okay? But the slopes have to be the same. So the one I used in class was y equals 2/3 x plus 3, and y equals 2/3 x minus 3. So those have the same slope, but they're starting from different points, right? So if I graph the top one, y equals 2/3 x plus 3, it's going to start here, and it's going to go up 2 over 3, 1, 2, 3, and that's all the further I can go. But then I can do the opposite, right? Go back to your beginning point, do the opposite. So down 2 to the left 3, 1, 2, 3, and go down 2, 1, 2, over 3, 1, 2, and 3. So I would have a line that looks like this, right? This other line is the same slope. It just starts at a different point. So yeah, I'm going to cheat here a little bit, and I'm just going to start it right there. There it is. Okay, it starts at negative 3, so I did, but it's going up by the same amount. They'll never intersect. They're parallel. Okay, so that's the key part there. Let's put it, whoops, let's get on the marker here. Let's put a little box around that. So one solution, slopes are different. No solution, slopes are the same, but the y-intercepts are different. And then finally, the infinitely many solutions, everything's the same. Infinitely many solutions means every single point they intersect. We'll think about what that would mean. It means the same line. So slopes are the same. Slopes are same, and the y-intercepts are the same. Okay? Everything's the same. Slopes and the y-intercepts. So, what would that look like? Typically, let's do y equals 2/3 x plus 3. So similar to that last one. I mean, if you're looking at two equations and they're both written in slope-intercept form, wow, my goodness, that's the best. It's like, oh yeah, I can clearly see the slopes are the same and the y-intercepts are the same. But for this example, maybe I'll give you one where that's not the case. Maybe I'll give you one in slope-intercept form like I did, and one in standard form. So the one in standard form, let's say I have, I don't know, 2x minus 3y equals -9, okay? And in this case, you would solve for y, and you would see, oh yeah, we get the exact same equation, right? If I subtracted 2x from both sides and then divided both sides by -3, I'm going to get the exact same equation, the same slope and the same y-intercept. So it's really just going to here and then up 2 over 3, and then going down 2 over 3 and down 2 and over 3 one more time. It's that. And when you solve the other one, maybe I'll change colors. You solve the other one, you're like, oh, hey, look, I get the exact same points. Yeah, that's why it's infinitely many solutions. Okay? So on the next page, page 4, really, if you know what to look for, these aren't so bad. You just have to know what to look for. Look for the slopes and look for the y-intercepts, especially these first 4. So for these first 4 problems, it says examine each set of equations, don't solve or graph, determine whether each system has one solution, no solution, or infinitely many solutions. Well, for number 1, I mean, take a look. 1/4, 1/4. Same slope. -5, -5. Same y-intercept. If everything's the same, that was the one we just did, I'm going to abbreviate. It's infinitely many solutions, IMS. Okay, whoops. Don't know how to get rid of that. There we go. For number 2, take a look at the slopes and the y-intercepts. Here, this top equation, my slope is -1. There's no number written there, so I know it's a 1, but there's a negative sign, so it's -1. For the second equation, it's -7. Slopes are different. Right away, that's it. You're done. That's all you care about. If the slopes are different, that's like our first 4 problems from the homework that we did. It's going to be one solution. So one solution. For number 3, look at that. -2/3, -2/3. Same slope. But the y-intercepts aren't the same. So it's not IMS. It's not one solution. It's the one we haven't done yet. It's no solution. And then for number 4, I see the parentheses there. We see a number written outside parentheses. You got to distribute for that second equation. 3 times x is 3x. 3 times 2 is 6, right? After you distribute there, you get y equals 3x plus 6. Well, that's what the top equation is. It's the exact same equation. Okay, and that's what I was trying to tell you. They're not always going to do it like number 1, where it's like, oh, everything just looks exactly the same right off the bat. Sometimes they do it like this, or they'll even do one where one is in standard form. Okay, so in this case, it is infinitely many solutions because everything's the same, slope and the y-intercept. Now for 5 and 6, all that work we just did on the previous assignment, solving for y, getting y by itself, think about what the slope number came from. The slope number came from the numbers that go with x and y, because you're subtracting the x to bring it over. I guess the camera's backwards. So you're subtracting the x. No, I did that right. You're subtracting the x and you're bringing it over to the other side. Okay, so I would subtract 2x, and then I would divide by 3. So my slope is derived from these numbers. So slope, I get it from subtracting that x and then dividing by that number by y. So it's going to be -2/3. Your y-intercept is this guy divided by the number in front of y. So 5 divided by 3. So I don't have to actually do any work. I can figure this out, okay? And I see, oh, hey, look. This one, the slopes, they're going to be the same because it's going to be subtract 2 and divide by 3, -2/3. But the y-intercept, how I get the y-intercept, It's going to be 15 divided by 3 because I have to divide everything by 3. I have to divide everything by that number in front of y. It's different. So when the slopes are the same, but the y-intercepts are different, that's no solution. And I can use that too, or I can use that also for number 6, right? These numbers are what's going to make up my slope. So it's going to be subtract 4x from both sides and then divide by -5. So -4 divided by -5, that's just positive 4/5 for my slope. For the bottom one, I've got subtract 8x and then divide by -10. So negative divided by negative, that's a positive 8/10. Do you see something here? This is just the same thing, but 8/10 isn't simplified, right? So slopes are the same, and then the same deal for the y-intercept. If you'll notice, it's just going to be 7 divided by -5. So 7 divided by -5, and it's going to be 14 divided by -10. Same thing again. Do you see that? It's just not simplified on the bottom. So because the slope and the y-intercept are the same, it's IMS, infinitely many solutions. And then for 7 and 8, you do have, you know the slope for the top equation, you know the y-intercept for the top equation. What you don't know is the slope and the y-intercept for the bottom equation. So let's get y by itself. I mean, this practice is good. This is good. So I'm subtracting x, get rid of the x term first. I've got 2y equals -x plus 12. I always put the x term first, right? And then divide both sides by 2. Well, that gives me, in place of that equation, y equals, because these cancel, -1 over 2x, and then 12 divided by 2 is 6. Look at the top equation. That's the exact same thing. So that's IMS, infinitely many solutions. And then for number 8, same thing. I can tell what the slope is from the top equation. I can tell what the y-intercept is from the top equation, but I can't from the bottom one. So I've got to get y by itself. Now, luckily for us, that means just getting rid of the x term, because then the y is by itself. Y equals, and that's -3x. I'm going to put that first, and then the -4. So you look here, slopes are different. When the slopes are different, it's just one solution. All right, moving on, last page of this. So we're on page 5 now. I've got this systems of equations, and it says 3 equations. A system just means more than one. So, I mean, we could have as many equations they could come up with. But I've got these three equations I'm going to be dealing with. It says Isabel needs to have the carpets cleaned in her house. She calls 3 different companies to get an estimate. Company A charges $30 per room to clean. Company B charges a $60 water disposal fee and $15 per room to clean. Company C charges a $100 water disposal fee and $10 per room to clean. It wants us to label the 3 lines, write an equation, complete the table, and then finally answer the questions, okay? So I'm going to do this out of order a little bit. I'm going to write the equation first, and I'm going to write the equation first because I noticed something, and some of you probably did as well. This word right here for all 3 of these companies. They use that word per. Now that sticks out because I remember if I see the word per, each, or every, those are words that are used a lot of times to describe the slope, the rate of change. Those are words to describe a rate of change. So if I look, for company A, there's that word per, boom, there's $30 right beside it. That's my slope. So I'm going to start with these equations. For company A, it's y equals 30x. That's it. That's it. They don't say anything about any fees. It's just $30 per room. So y equals 30x. For company B, they have that other fee. right? So I know my slope is 15. It says $15 per room. So it's y equals 15x. But then they have that added on fee of $60. So that's plus 60. In other words, that's your y-intercept. And then for company C, again, there's that word per. I know right away my slope is 10. But they have that additional fee of $100. So that is your y-intercept. Okay. Now, that makes labeling these lines, so this part right here, way easier. Okay. If I know the equation for each line or for each company, it's going to make it that much easier to match up with the lines there. Okay. Company A starts at the origin, starts at 0 because it's just y equals 30x. Well, that's this line right here, right? Company B starts at 60. 60 is right here. That would be this line here. And then company C starts at $100 and goes up 10. It would be this line right here. So once you have the equation, man, it makes it so easy to look at the y-intercepts and say which line is which. So I labeled the 3 lines. The next thing I'm going to do is go ahead and start filling out the table. If you remember, this is good reminder. From a table, if x equals 0, the y value is the y-intercept. So I know the y-intercept for all 3 companies, and they have for where x equals 0 here. For company A, we said the y-intercept was 0. For company B, we said it was 60. And for company C, we said it was 100. Okay. Then I'm just going to use my slope. I mean, you could look at the table. Look at the table. We're filling in the table. You could look at the graph and see what these numbers are, but I think it's just as easy to use your slope from your equation to fill in the rest of the table. They're counting by ones going down the x values of this table. So you're going to just use the slope to count by that, right? So for company A, it's $30 per room. So I'm just counting by 30s from 0. So 30, 60, 90, 120, 150, 180, 210, 240, 270, and then finally, if there are 10 rooms, that's $300. And you can see that checks out with my equation, right? I always check the last one just to make sure I didn't make a mistake somewhere. If I put in 10 for X, 30 times 10, whew, that's 300. No mistakes. All right. For company B, they're just increasing by 15 each time. Okay? So 15, counting on from 60, from that y-intercept. So 60 plus 15 is 75. Then 90. Then 105. All I'm doing is adding 15 each time. 105 plus 15, 120. 135. 150. 165. 180. 195. And then 210. Okay, so initially starts out cheaper, but in the end, initially starts out more expensive, with that y-intercept at 60, but in the end, it's cheaper for company B compared to company A. Check the last line real quick. Put in 10 for X, right? If I'm using that equation, 15 times 10 is 150. 150 plus 60 is 210. And that's what I got. So far, so good. And then do company C. Okay, company C, the slope was just 10. So I'm just increasing by 10 each room. So counting on from 100, that's 110, 120, 130, 140, 150, 160, 170, 180, 190, and then 200. So I mean, that's kind of interesting, right? Company C started with the highest amount, started with 100, but it ends with the lowest. It ends with 200, whereas the other 2 companies are at 210 and then 300. Okay, so I can use the table or the graph or the equation to answer these questions. It says if Isabel only wants 2 rooms cleaned, which company should she choose? So I'm going to use the graph for this first one. I'm going to try and use different methods to answer these questions, but I'm going to use the graph. If I only want 2 rooms clean, I'm going to go from 2. Now, this line here is at 60, and that is, well, what line is this? See, it's a good thing we labeled them. It's all the way up here. That's line A. That's company A. So from the graph, company A is $60. Okay, if I keep traveling up from there, it hits this line halfway between 80 and 100, so that's 90. So that would be company B. I can see the line that I labeled right there. That's company B. And then if I keep traveling up, boom, it hits company C right there at 120. Company C is 120. So, which company should she choose? That answer, what color do I want to do? Let's do black. That answer is company A. So I explained where I got my work, so it's graph, from the graph, company A. It's the cheapest, right? So question C down below that says, well, when would company A be your best choice? Okay, well, I can see that from the table. I'll try and answer that one from the table. If I go across this table here and just look and see company A for 0 rooms, okay, well, that's not going to happen. So let's start at 1. For just 1 room, company A is 30, then 75, and then 110. It's company A. For 2 rooms, we already said it was company A. There's 60, 90, and 120. For 3 rooms, company A is still cheaper. 90, 105, and 130. And for 4 rooms, company A is at 120, company B is at 120, company C is at 140. So at 4 rooms, it's still the cheapest. It's tied for the cheapest, but it's still the cheapest. So anywhere from 1 to 4 rooms, I would use company A. And I'm going to say that in my answer. So from the table, company A is the cheapest from 1 to 4 rooms. Okay. Now after that, not the cheapest anymore, right? Starting with this 5th one, I can see, oh, company A is 150, company B is only 135. Okay, company C is also 150. So it went from being tied to the cheapest to being tied to the most expensive in just 1 room. All right, but let's answer the next question. So question D says, when would company B be the best choice? Show all of your work, explain your answer. So company B, we just pointed out, starting with room 5. So I'm going to use the table again. So table. Starting from room 5, company B is the cheapest. I don't need to focus on company A anymore. I know company A is not the cheapest. So I'm just going to focus on company B and company C. It's the cheapest for room 6, or for 6 rooms also, because 150 is cheaper than 160. It's cheaper with 7 rooms, 165 compared to 170. For 8 rooms, it's tied. They both cost 180. Okay, so from the table, I can see from 5 to 8 rooms, even though on the 8th room it's tied, it is still the cheapest, right? So from 5 to 8 rooms, company B is the cheapest. And then what happens after that, right? So from 9 onward, look at what's the cheapest, right? 190 compared to 195 compared to 270 for 9 rooms for company C. 200 compared to 210 compared to 300 for 10 rooms for company C. So when would company C be the best choice for 9 rooms or more? Just because our table stops at 10 rooms doesn't mean houses stop at 10 rooms, right? Yeah, a house can have more than 10 rooms. So I'm going to say for 9 rooms or more. And again, that was from the table. But again, I could have answered that from the graph. I could have used the equation. There's lots of ways to answer that question. All right. If you guys have any questions with systems of equations, make sure you ask your teachers.